Hello everyone, today we will study the chapter difference equation. This chapter is mainly associated in mathematics for economics, but it can come in other subjects as well. So, in this difference equation, the question will be given as a function. The objective function of the question will be given. So, let's say objective function is given y t plus 2 plus alpha y t plus 1 plus beta y t equals to gamma. So this is a second order difference equation, right? This is a second sorry second order difference equation. This is an example of a second order difference equation. In this alpha, beta and gamma, these three are actually constants. This alpha, beta and gamma are constants. Then we need to find the general solution. So what is the general solution? General solution y equals to yp plus yc. Now what are these yp and yc? Yp is a particular solution. And yc is a complementary solution. Right? Yeah. So yp is the particular solution and yc is a complementary solution. We need to determine the value of yp and yc in order to get the general solution. Now how can we determine the value of yp? So how to determine the value of yp? It's pretty easy. Yp equals to gamma by 1 plus alpha plus beta. Now what is that? We have got from the second order differential equation, there is 1 as a coefficient here, alpha as a coefficient here, beta is as a coefficient here. So we will simply divide this gamma by the coefficient 1 plus alpha plus beta. Okay. By this we will get yp. We will get the value of yp, which will be a constant. So this is actually a constant because we're actually dividing a constant by a constant, so therefore the answer will also be a constant, right? So gamma is a constant here, 1 is a constant, alpha is a constant, beta is a constant, so yp is also a constant, right? Now how to determine the value of the complementary solution? This is a particular solution, right? Particular solution. Now how to determine the value of the complementary solution? Let me write this. How to determine the value of the complementary solution. Now first we need to keep one thing in mind, that for complementary solution we consider only the homogeneous part of the difference equation, right? we consider only the homogeneous part, which means that this part, this constant part, this gamma part will be 0. So we will consider the gamma part as 0 and we will consider only this part. This part we will only consider and equals to 0, which is the homogeneous equation. So let me write homogeneous equation equals to y t plus 2 plus alpha y t plus 1 plus beta y t equals to 0. So this is our, sorry, this is our homogeneous equation. We only consider, will take the value from this part. Okay. So how we will get yc, which is the complementary solution? How we will get this? First, we will solve this by trial method. Okay, we will solve this by trial method. Oh, what is trial method, right? We will consider y equals to a b to the power t, right? A b to the power t. Therefore, y t plus 1 equals to a b t plus 1. Here a is any other constant which value we will find later on. So, and y t plus 2 equals to a b t plus 2. The simplest method. So a b to the power t, a b to the power t plus 1, and a b to the t plus 2. We will replace these values here in this homogeneous equation. To replace these values, so we will get something like a b t plus 2 plus alpha a b t plus 1 plus beta a b per t equals to 0, right? So this I put equation 1 and I'm writing here, putting the values of yt plus 1, sorry, write it properly, t plus 1 and y t plus 2 in equation 1, right? We get this. Yes. Now we can take common, right? We can take common a b to the power t. So if we take common a b to the power t, a b to the power t, if we take common, then b square plus b plus, sorry, b square plus alpha b plus beta equals to 0, and we get a quadratic form, right? B square plus a constant b plus some constant equals to 0. We get a quadratic equation, and we can reduce this will go here and it will become 0, and b square plus alpha b plus beta equals to 0. Therefore we get a quadratic equation. This equation is called the characteristic equation. This equation is called the characteristic equation. Okay, now we need to find the value of b. We know that we learned this in class 10 or something like that, the Siddharth Acharya rule. So what is that? B equals to, how to find the value of b? B equals to minus b plus minus root over b square minus 4ac by 2. Here I am writing not 2a but 2 because b square will, the coefficient of b square will always be 1. Therefore, I am writing 2 or 2a is 2. So no problem with that. So yeah, this is the value of b. When we will get the value of b, we will get the characteristic solution, right? So we get the value of b. After that, after getting the value of b, we will get 3 cases to find yc. We will get 3 cases. What are the cases? Case 1. Case 1, right? If we get the roots, that is the values of b, real and distinct. Real and distinct. If we get the values of b as real and distinct, that is both are real numbers and both are distinct, which that is both are not equal, then we get yc equals to a1 b1 to the power t plus a2 b2 to the power t. Okay, so this is the equation we get of yc when the values of b's are the value of b is values of b are real and distinct. Okay, now second case, case 2. If we get repeated real roots, then yc equals to a1 b1 to the power t, sorry, let me write it properly, a1 b1 to the power t plus a2 t b2 to the power t. Okay, there will be only one extra t in front multiplied to a2, right? So this is the case when the this is the case when the values of b's are equal and real. Okay, if the value of b which we get from here is real and equal with each other, both are equal numbers, then we get this condition. If we get repeated real roots, then yc, the value of yc will be this. Okay, and if we don't get that repeated real roots, that is both are distinct and real, then the case is this. And lastly, case 3, if we get complex conjugate roots. If we get complex conjugate roots, okay. If we get complex conjugate roots, then yc equals to r to the power t. Sorry, here it will be r to the power t a1 cos t theta plus a2 sin t theta. Theta equals to, we know this, right? We know this what theta is, v by tan inverse v by u, where v is the imaginary part and u is the real part, right? R equals to root over u square plus v square, which is modulus. We know this. We have learned this in previous classes that R is the modulus, which is root over u square plus v square, and theta, which is amplitude, is the tan inverse v by u, right? We have learned this in previous classes. So yeah, we get how to find yc and yp, and simply we will add them to get the general solution. General solution. Where is the general solution? Let me, to get this. Our main objective is to find this y, the general solution, and to find this, in order to find the general solution, we must first find this yp, and after that yc. We get three conditions how to find yc, and we will shortly learn this in an example. Example follows, and with the example I will show you how to solve the sum, right? But the main process is this, the steps, the process, you can say this is the process. Okay, now there is another thing which we should keep in mind. The oscillator oscillatory and non-oscillatory movements and divergence and convergence, right? So only there is some conditions, you just write it so that you don't forget. Non-oscillatory. Okay, so what is non-oscillatory? These are basically difference equations are basically time graph. So if the graph is non-oscillatory, then b greater than 0. If b greater than 0, then we can say that the graph is non-oscillatory. Okay, and if b is less than 0, we can say that the graph is oscillatory. So, and divergent, if b modulus of b is greater than 1, then divergent, and if modulus of b less than 1, then convergent. Very simple. Sorry, I have the spelling of this wrong. I just corrected. Right. So done. So these are the basic conditions. You get the idea. After that, after this I will just solve a sum and make everything clear to you. Okay. Okay. So this is an example. Okay. So example. Let me write it. With another color. Example. Right. So there is an example, an objective function yt plus 2 minus 2yt plus 1 plus 2yt equals to 1. This is the question which is given. Okay. Another additional information is given that given y0 equals to 3 and y1 equals to 4. y1 equals to 4. Right. There is an additional information given. So let us first compare with the solution. Let's first compare with the main equation which I had written. So y t plus 2 plus alpha y t plus 1 plus beta y t equals to gamma. So from here we get, comparing this equation and this equation, we get alpha equals to minus 2, beta equals to 2, and gamma equals to 1. Right? Alpha equals to minus 2, beta equals to 2, and gamma equals to 1. Our main objective, what is our main objective? To find y, general solution, right? General solution. Y equals to yp plus yc. Our main objective is to find this yp and yc, where yp is the particular solution, and yc is the, sorry, not, it's complementary solution, right? So yp is a particular solution and yc is a complementary solution. Our main objective is to find this two. So let's first find yp. yp equals to, as I have written earlier, gamma by 1 plus alpha plus beta. We have got the values of gamma 1 by 1 plus we have got the values of beta and alpha. What is beta? 2. And what is alpha? Sorry, first we have to write alpha. What is alpha? Minus 2. And what is beta? Plus 2. Right? Equals to, we get 1 by 1 because this plus 2 and minus 2 get cancelled out. So 1 by 1 equals to 1. Right? So we get the value of yp equals to 1. We get this. Right? After that, we need to solve the complementary solution. Particular solution is basically very easy, finding the value of particular solution. But now it's time to find the value of complementary solution. So this is particular solution, finding the value of the complementary solution. How to do that? So we have first known that we need to use trial method. Trial method, right? Need to use trial method. So in trial method, we have to substitute the value of y. So y equals to ab to the power t, y t plus 1 equals to ab t plus 1, y t plus 2 equals to ab t plus 2. And we know that we need to always consider the homogeneous part of the difference equation, right? Therefore we have the homogeneous part. What is the homogeneous part of the difference equation? This yt plus 2 minus 2 yt plus 1 plus 2 yt plus, okay, I should write it properly, plus 2yt equals to 0, because this gamma will always be 0 in case of homogeneous equation. So this is our homogeneous equation. Just mark it out. Homogeneous equation. Now we'll substitute these values in the homogeneous equation. We'll substitute this value of y, yt plus 1 and yt plus 2 in our homogeneous equation. So we get, substituting the values we get ab t plus 2 minus 2 ab t plus 1 plus 2 ab t equals to 0. Taking common ab to the power t, we get b square minus 2b plus 2 equals to 0. Now we know how to solve this. We have learned it previously. B equals to minus b plus minus 2 over 4. Sorry, b square minus 4ac by 2 equals to minus, oh sorry, I have not written this equation, b square minus 2b plus 2 equals to 0, because this part, as you know, will be 0. Now we are finding the values of b. So minus b, so minus 2 plus minus 12 whole square minus 4, a is 1 into c is 2, right, divided by 2 equals to 2 minus is plus, so 2 plus minus 4 minus 4 into 2 8 minus 8 by 2. So we are getting that on under root we are getting a negative number. Therefore it is a case of complex conjugate roots, as we have discussed earlier. 2 plus minus 2i, right? This will be 4. Here it will be minus 4. We are taking I as root over minus 1. So 2 plus minus 2i by 2 equals to 1 plus minus I, right? 1 plus minus I. There is a case of complex conjugate roots. Therefore, this is a case of complex conjugate roots. How to solve complex conjugate roots, this also we have done earlier. I have taught you earlier. So case 3, which was case 3. What was case 3? Yc equals to r to the power t a1 cos t theta plus a2 sin t theta. Right? Okay. So here r, what is r? R we have known r is a modulus. So r equals to root over what? V square plus u square. So v is the imaginary part, u is the real part. So we get 1 square plus 1 square, 1 square plus 1 square equals to what? 2. Right, root over 2. Yes, root over 2 is the answer. Value of r. Now, to find the value of t, right? We need to find the value of theta, not t theta, equals to tan inverse p by u. So tan inverse 1 by 1 equals to pi by 4, right? Because tan inverse 1 we know is pi by 4. Therefore, substituting this value in equation, let's say equation 1, we get yc equals to, what is the value of r? Root 2 to the power t. What is tan inverse pi? What is theta? Pi by 4, right? So a1 cos t pi by 4 plus a2 sin t pi by 4. So this is the value of yc, but there is something unknown. We don't know the value of t, so we need to find the value of t. Remember one thing, there was some additional information given in the question. So in the question it was given that y0 equals to 3 and y1 equals to 4. Okay, so at first we will put t equals to 0. Great. So the general equation, first let me write the general equation, then we will solve that a1 and a2. So general equation y equals to yp plus yc, right? So y equals to, what is yp? 1 plus what is yc? Root over 2 whole to the power t into a1 cos t pi by 4 plus a2 sin t pi by 4. Okay, there is a general equation. We get this. Okay, we get this. Right. Now we will get the values of a1 and a2. Now let us put y0 equals to, actually there is a t here, okay, t. Therefore we are putting that t equals to 0, so the value of t will become 0. So 1 plus, you can write it y or yt or whatever, okay, but generally it is given as y or yt. So 1 plus root 2 0, okay, there is no problem, 0, okay, and a1 cos 0, because t into something 0 is 0, plus a2 sin that t in 0 0. Okay, so we get, but there was given that y0 equals to 3, right? Y0 equals to 3, it was given here. Therefore we will simply substitute that 3 equals to 1 plus root 2 0 1 into root 2 to the power 0 equals to 1. So a1 cos 0 is 1 and sin 0 is 0. So a1. Therefore, sorry, there is something going on. What to do? Therefore, 3 equals to 1 plus a1. Therefore, a1 equals to 2. We get the value of a1. Similarly, there was another thing given that y1 equals to 4. So if we put the value of y equals to 1, if we put y equals to 1, which means t equals to 1, sorry, y1 was given, so t equals to 1, so this was y0, it was 0, and now it was 2, y1 equals to 1 plus root 2 to the power 1, a1 cos 1 into root pi by 4 equals to pi by 4 plus a2 sine I by 4, right? Yeah, equals to 1 plus root 2 into a1 1 by root 2 plus a2 1 by root. Taking root 2 common, we get root 2 into 1 by root 2. This will cancel out. a1 plus a2. So what was the value of y1? What was the value given in y1? It was given 4. Sorry. The value of y1 was given 4. Right. The value of y1 was 4. So we will do that. We will substitute y1 as 4 equals to 1 plus a1 plus a2. Right. 1 plus a1 plus a2. Now we know the value of a1. We have taken out the value of a1. So we'll put the value of a1 1 plus 2 plus a2. Therefore, a2 equals to 4 minus 3 equals to 1. Therefore, the value of a2 is 1 and the value of a1 is 2. Therefore, finally we get the equation yt or y equals to yp plus yc. Okay, so yt equals to 1 plus root 2 to the power t. a1, what is a1? 2 cos t into pi by 4 plus what is a2? 4. Oh, sorry, 1. What is a2? 1 sine t pi by 4. Okay, and 1 we shouldn't write like this, it will be that. This is the answer, right? This is the answer. So I'll just mark it. This is the answer. Now, like this, we will do distinct and repeated roots, which is given in another video. But this is actually the longest part. This is a complex conjugate root. This is like a little bit confusing. That's why I have explained it. And others are very easy. And other example, if you want to still try the other examples, that is repeated real roots and those real and distinct roots, that's case 1 and case 2, then you can watch my next video or watch another video. Okay, thank you.